Hello everyone. Today we are going to present our IBP project on face recognition with histogram of oriented gradients. So our team members are Manikanta Ginige, Mugli Dinesh Reddy, Navin Kumar Kasa, Praneet Kumar Tetabhavi and me Vaishali Bhagwani. Our project is mainly based on face recognition and detection. Face recognition is becoming one of the most actively researched problems in computer vision. The available literature is increasing at a significant rate, and even the number of conferences and special issues entirely devoted to face recognition is growing. Our project is mainly based on face recognition and detection, and we will be doing face recognition using histogram of oriented gradients. Histogram of oriented gradients, also known as HOG, is a feature descriptor like the Canny Edge Detector SIFT, which is a scale invariant and the feature transform. It is used in the computer vision and image processing for the purpose of object detection. The technique counts occurrences of gradient orientation in the localized portion of an image.
These are the steps to calculate histograms of oriented gradients VHS. First of all, take the input image you want to calculate the VHS of. Resize the image into an image of 128 cross 64 pixels. The first figure shows the image imported to get histograms of oriented gradient VHS. Second figure shows the imported image grayscale for the process. Third figure shows resized and grayscale image of the imported image. The gradient of image is calculated by, by combining magnitude and angle from the image. Considering a block of 3 cross 3 pixels, first Gx and Gy is calculated for each pixel. After obtaining the gradient of each pixel, the gradient matrices are divided into 8 cross 8 cells to form a block. For each block, a 9-point histogram is calculated. A 9-point histogram develops a histogram with 9 bins, and each bin has an angle range of 20 degrees. A 9-bin histogram is in which the values are allocated after calculations. Each of these 9-point histograms can be plotted as histograms with bins outputting the intensity of the gradient in that bin, as a block contains 64 different values. For each cell in a block, we will first calculate the jth bin and then value that will be provided to the jth and the j plus 1th bin respectively. The value is given by the following formula, three formulas. An array is taken as a bin for a block and values of vj and vj plus 1 is appended in the array at the index of jth and j plus 1 bin calculated for each pixel.
Hello, my name is Pranit, and I am here to explain you about the project which we have created for the face recognition using histogram oriented of gradients. Here I am going to explain you about the normalization using L2 norm, which plays a crucial role to reduce the effect of lighting in variations and to calculate the normalization factor, that is K, uh, which is used to uh, we will be using this normalization factor and dividing with each pixel to get the normalized array of the pixels. And I'm going to explain you about the total length of HOG features. The total length of HOG features vector is calculated by multiplying the number of blocks in both directions with the number of features per block. In example, it is 7. In example, it's 7 horizontal blocks multiplied by 15 vertical blocks into 36 features per block, totaling 3780 features. And here comes to this seventh step. In seventh step, if we consider this image, in image we have a Stride consists of 8 pixels. In this, each blocks consist of 2 cross 2 structure. Each block consists of 4 cells, which is a 2 cross 2 structure. To create this feature vector of for a block, you concat the 9-pin histograms for each of the cells, resulting in 36 element features vectors of each block. These blocks are formed with an overlap here, a stride of 8 pixels, indicating that each block shares cells with its neighbors, which contributes to the robustness of the feature descriptor. And the resulting vectors from the final HOG descriptor that characterize the local gradient information through the image. Here completes the 7th step, and if we comes to the 8th step, in 8th step we have the formulas. Here FPI is known as the feature vector for block I, and the squared norm for the featured vector, which is sum of the squares of its element. And epsilon is a small constant added to avoid division by 0, often a tiny value like 10 power minus 5. By this formula, we will be normalizing the each pixel value using L2 norm. And coming to the next step, here we have used this k to normalize the whole vector, and the k is the summation of sum of squares of each pixel value. And here FPI value uh, is obtained by using the division of the each pixel by the total k value. Uh, the output of these formulas will be normalized feature vector for each block, where each element is scaled down based on the overall magnitude of the vector, making it invariant to changing the lighting and shadow. And here comes the 10th block. 10th step, the normalization is done to reduce the effect of changes in contrast between images of the same object. For each block, a 36 point feature vector is collected. In the horizontal direction there are 7 blocks, and in the vertical direction there are 15 blocks. So the total length of HOV feature will be 7 into 15 into 36, that is 3780 HOV features of image are obtained. Here it is the final form of the image. Basically what we have created is we are obtaining features of the consider them like face or hands by using the histogramic value. If the pixel is dark, then the histogram value will be high. If the pixel is low, then the histogram value will be less. That's the basic fun of this HOV features. Basically it obtains the uh, value by using these uh, detects the value by using these gradient frequencies. Thank you.
Landmark localization. The goal was to access the effectiveness of a special facial landmark localized approach. This method involves automatically extracting 49 distinct landmarks positions from each facial image. The core technique used for this landmark localization was based on active appearance models. To initiate this process, first a set of landmarks are being established. Like we can see the red color dots established in the image. These are not fixed or standard landmarks. Then the experiment involves extracting histogram of an oriented gradients descriptors from the image. These descriptors are crucial in capturing the edge of the images. Two different patches size were used for extraction. You can see the second image is 24 cross 24 and third one is 34 cross 64 cross 64, varying in sizes. The varying in sizes and this extraction and representation of the facial features can be clearly visible in the last image. Facial database. The given table consists of some of the facial database. The first one is the FPRT database. The database contains the images from 1900 different classes and in total of 3540 sample images. The number of sample per class varies with minimum of 2 and average of 2.1 and maximum of 32 images. The variation present in these images includes facial expressions, aging of subjects, and difference in light. Next, the next database is MPIE2 database with 377 classes, and the database includes 2509 total images. Each class has minimum of 2 and average of 7.4 and maximum of level samples. This image captures variations in expressions and different sessions. Next, AR database. The AR database is composed of 132 classes and total of 3236 images. It has a large number of samples classes. 13 minimum, 24.5 average, and 26 maximum. Compared to other databases, the images have varied in terms of facial expressions, lighting, conditions, and occasional such as sunglasses or scarf. Next, AL database. This is the smallest database mentioned with the 15 classes and 165 total samples, with equates to level samples per class. The variations in the database includes facial expressions, lightings, difference, and presence in classes.
Myself Navyant. Now I will show the implementation part of our project. Initially I am not giving any dataset here so that no one can access the quiz right now. I will share the encodings now. Now I will run the comparing encodings Python script. You can see I am unable to access the quiz right now as I have not given any data right now. Now I have given the image dataset, my image in here, you can see it. Now I will save the encodings. Now I will run the compare encodings Python script. You are able to see that my photo is authenticated successfully. Now the quiz will open shortly. You can see here I am now able to access the quiz. I am answering the quiz. You can see here I am able to see my final score here. The code works in this way. Thank you.